Hello friends, welcome to our student support program for grades 10 and 11 in additional mathematics. In today's session, we are going to look at quadratic functions, that is, how to find the conditions for the roots of quadratic functions. So let's start. So today we are going to learn about the conditions for f of x to have two equal roots, two real roots, and no real roots. Let's see. Now, when we talk about the roots of quadratic equations, what are we referring to? Well, the roots of a quadratic equation are simply the solutions of the equation, right? So when you see roots, that's simply the solutions of the equation. Now, to find the solution of an equation, what do? Well, we use factorization, or we use the formula given by x equal to minus b plus or minus square root b squared minus 4ac divided by 2a. You know that already. Now, there is a term that we use. This term is discriminant. So the discriminant is simply b squared minus 4ac, right? You know where does that come from now. So let's take an example. Let's consider this equation y equal to bracket x minus 4 whole to the square. What can we say? Well, at the x-axis, remember x-axis, y should be equal to 0. That's right. So x minus 4 to the square equal to 0. Solving this equation, what do we have? Well, x minus 4 times x minus 4 equal to 0. X will be equal to 4 or 4. So, what can you notice here? We have two repeated, or what we say, two equal roots. That's the function y equal to x minus 4 to the square. Now, let's consider the equation y equal to bracket x minus 4 close bracket to the square. Well, x-axis, we know that y equal to 0. So what do we have? We have x minus 4 to the square equal to 0. When we expand it, we are going to get x squared minus 8x plus 16 equal to 0. So here, in this case, we have a equal to 1. Remember, a is the coefficient of x squared. B, coefficient of x, will be negative 8, and c equal to 16. Now, using the discriminant in this case, well, our discriminant is given by b squared minus 4ac. So that will be minus 8 to the square minus 4 times 1 times 16, which will be 64 minus 64, and 64 minus 64 is 0. So what can we say? Well, we note that when we have two repeated roots or equal roots, b squared minus 4ac should be equal to 0. Now let's take a second example. If we consider this equation, y equal to x minus 3 times x plus 2. Now, x-axis, we have y equal to 0. So if we replace y by 0, we are going to get x minus 3, x plus 2 equal to 0. You know how to solve that. So we shall get x minus 3 equal to 0 or x plus 2 equal to 0. So that will be x equal to 3 or x equal to minus 2. Now, are these two roots equal? No, because we have 3 and negative 2. So we have two real and distinct roots. That is, the curve will cut the x-axis at two distinct points. That's the curve. It will cut at 2 points. Now, if we consider the same equation, that is y equal to bracket x minus 3, close bracket, bracket x plus 2, at the x-axis we know that y equal to 0. When we expand it, we are going to get x squared minus x minus 6 equal to 0. So here, a will be equal to 1, b equal to negative 1, and c equal to negative 6. Right, if we use the discriminant, b squared minus 4ac, you just need to replace the value of b, of a, and of c. So that will be minus 1 to the square. Remember to put the brackets. Minus 4 times 1 times negative 6. So that's 1 plus 24, which is 25. What can we say? Well, we can say that when we have two real and distinct roots, b squared minus 4ac should be greater than 0. Example 3. Let's consider the quadratic. Bracket x plus 2, close bracket to the square plus 3. Well, x-axis, you know that now. Y should be equal to 0. So when we solve it, we are going to get x plus 2 to the square equal to negative 3. So x plus 2 will be square root of negative 3. So for grade 10 and 11, what do we say? Well, we say that we have no real roots because for this grade 10 and 11, you cannot solve square root of negative 3. Right? So, no real roots, that is, the curve does not cross the x-axis. Here, the curve is above the x-axis, so it does not cross the x-axis. If it does not cross the x-axis, we do not have roots. Now, let's consider this equation. Y equal to x plus 2 to the square plus 3. Now, x-axis, y equal to 0, we know that. Let's expand it. What are we going to get? We are going to get x squared plus 4x plus 7 equal to 0. Right. Now, coefficient of x squared is 1, that is a equal to 1. B will be equal to 4 and c equal to 7. So, we use the discriminant, b squared minus 4ac. What are we going to get? Well, b, that is 4. So, 4 to the square minus 4 times 1 times 7. That will be 16 minus 28. And 16 minus 28 is minus 12. What do we say? Well, we say that when we have no real roots, b squared minus 4ac is less than 0. So for the nature of root, we consider the quadratic equation y equal to ax squared plus bx plus c. This table is very important. Just be careful when you are working. When we have the discriminant equal to 0, what do we say? Well, we say that the roots are equal or repeated. If b squared minus 4ac is greater than 0, we have real and distinct roots. And if b squared minus 4ac is less than 0, we say that we have no real roots or imaginary roots. Let's see an example now. The equation 4x squared plus 3px plus p equal to 0 has no real roots. Find the real values of p. Okay, how do we proceed? Since the equation has no real roots, we have b squared minus 4ac is less than 0. Now, let's look at the values for a, b, and c. In our case, a equal to 4, b equal to 3p, and c equal to p. So, b squared minus 4ac less than 0, we just need to replace the values for a, b, and c. That will be 3p to the square. Remember the brackets? Minus 4 times 4 times p, which is less than 0. 9p squared minus 16p less than 0. What do? We factorize. P into 9p minus 16 less than 0. How do we proceed now? Well, we look for critical values. So the critical values will be 0 and 16 over 9. Next step, number line. That's right. We put our values, that's 0 and 16 over 9. Is it a minimum or a maximum? Well, we look at the coefficient of x squared, that is a equal to 4. 4 is positive, so we have a minimum. And since it is less than 0, we look at the region where the curve is under the line, that is p will lie between 0 and 16 over 9. We take another example. Find the set of values of q such that x squared minus 3qx equal to minus 9 has two real and distinct roots. Now, real and distinct, what do we have? B squared minus 4ac is greater than 0. So that will be x squared minus 3qx equal to minus 9. That's the equation that we have been given. Now, just be careful here. Why do we need to be careful? Because the equation is not equal to 0. So how do we do it? Well, we make it equal to 0. How? You just move the negative 9. So we are going to get x squared minus 3qx plus 9 equal to 0. Therefore, a will be equal to 1, b minus 3q, and c equal to 9. What do we do now? You just need to replace in b squared minus 4ac. That will be minus 3q whole to the square minus 4 times 1 times 9, which is greater than 0. So 9q squared minus 36 greater than 0. When we simplify, we are going to get 9 into q minus 2, q plus 2 greater than 0. What do? Well, we are going to look for critical values. That's 2 and negative 2. Next step, you know that now. We move to the number line, negative 2 and 2. And then we do our curve. Now it's greater than 0, so we are going to look where the curve is above the line. So q will be less than negative 2 or q is greater than 2. Okay, so now a few exercises for you to practice. So friends, we have reached the end of our session on quadratic functions. Today we have learned together about the conditions for a function to have two equal roots, that is, b squared minus 4ac should be equal to 0. Two real roots, that is, b squared minus 4ac should be greater than 0. And then no real roots, that is, where b squared minus 4ac is less than 0. Now we have also worked some examples for you. What do you need to do now? You know it. You need to go through the exercises in your textbook and ask for help. So until we meet again, it's goodbye for now.